So, it's very, very simple. Like, so fucking simple that if you can't figure it out just from looking at it, and yeah, I don't know what to tell you here. We should have luck on that one. So, remove the light bulb. You obviously you know how to take the light bulbs out, right?
Yeah, I already replaced the light bulbs.
Okay, so these kind of lights...
Just can't get it connected right.
These kind of lights, it could be several different things. They're very simple to work, though. So, fluorescent tube. Glass tube, obviously you know this, but it's filled with gas. All the gases, that's why they make that big loud sound when they smash. They go boom, you know? Just because that's all that is a big vacuum full of gas. What happens is when a positive and a negative signal is introduced into the glass chamber, fills with this gas, it creates it makes the gas ionize and light up. Light. It's like those little swirly ones like you got up in your lamp right there, babe. It's just, if you let it get cold and then turn it on and look at it really, really closely and carefully, right when you first turn it on, for like the first few minutes of its life being on, you can see the gas itself inside the tube just moving really rapidly.
Really? I've never paid attention to it like that.
Because you really have to stare at it to actually to see the movement. Otherwise,
cool.
to most people, it just seems like it's a dull light, and then it gets brighter after it warms up.
Okay.
But it's actually because of the gas. It's like it's just like it's having a party.
Right.
So, right here, these bulbs, where they work is these two prongs right here are. Let me make sure, because there's different ones. Sometimes the negative will be ran this way through the ground, and that's the negative signal. But on these ones, I believe. Oh, there it is.
So is that my problem? I just put the lights in backwards, so that's why they won't stay lit? No?
No, it doesn't matter.
Okay.
I was just tracing the wire to make sure I was correct with what I was going to say. Alright, now if you look at this, you gotta really get in close to it if you want to see that detail. Notice how the wire itself, this side, has little lines on it? And then the other side is just flat. You can even feel it too. They're like cut into the plastic.
Yeah, I can see the
ridges.
Right.
If you trace that back to the end of the plug-in, you'll notice that right here as it enters the plug, so on the left side is the wire with the line, so that'd be that one. And then the flat, smooth one is this terminal. Do you remember that trick I taught you?
White guys live in big houses.
White men live in bigger houses. So, this is a white guy, that's a black guy. The white guy has the big head, remember that. The white guy's bigger. So now you know this wire with the lines on it, it's going to be what wire?
The white wire.
Yeah, so inside the wall, the white wire is a neutral. So that's your negative. black is your hot. That's your positive. So this would be your hot line. This is the one that's where the power is coming from. Like, it's all coming down here. AC and DC currents are different in the fact of DC is a direct current, to where, like, that's why you have to ground out your car battery, because that's where your negative terminal is going, is to the fucking body of whatever it is that it's connected to. And then the positive meaning you only have to have one power wire to power something, technically.
Yeah, but I usually think of black as being negative. So
yeah, because of that colors on the battery. But it's kind of, that's why I was explaining the difference between AC and DC. Direct current, red is your hot, and black is your ground, your negative. But in AC, what makes AC electricity different is the fact that it's exactly what does alternating current say to you?
the current alternates.
What's the word alternate mean?
It pulses or goes back and alternates from different states. I don't know.
That's a different definition of the word. I mean, alternating meaning, what does an alternator do in your car?
It runs.
Okay, what's running?
Powers the.
Keep going. What does it do?
The electricity of it makes it. I don't know. Spins.
It alternates. It spins.
That's what I said. It goes. Okay, I didn't say spin. It goes from one state to another. So, okay, it spins.
So, in what we're thinking of right now, alternating current. What does that tell you now?
It spins.
Yes. So what shape does spinning make?
A circle.
Okay. Now, alternating meaning a circle. Exactly. Keep that in your mind. So when you have your power source right here, negative, positive, or hot and neutral, in this case, because alternating current, follow it down. You see that the wire that is smooth connects to the switch where all the switch is. That's it. It just completes the circuit. So when you have it off, there's nothing connecting that wire to that wire. You turn it on, flip it over. Now those two wires are connected together. So now this is your hot line. This black one. As it comes out. So now if you look at here at the board that's inside the box, you can determine from looking at the board. So right here, we know this black wire entering the board is our power source. That's our hot line. So the white one next to it is going to be what?
The neutral.
Exactly. Now what are these two orange ones?
The ground.
Nope. If you follow them back, they just lead to this side of the light bulb. That's it. They just do the left side of the bulb. That's it. That side. That's it.
Oh, I didn't notice the ones going out that way, so that makes sense. It just makes that.
That just runs to that.
Okay.
So those are your power wires. These are just leads coming off your board. So then if you look on this side, same exact thing. The wire with the writing on it is going to this side, and the wire without the writing is going to that side. But if you look at this board, you notice both wires have writing. Why?
Because these are the same wire? Is that wire?
Yes, because the point of this board in the first place, like the very first, the reason it's in here, is because this wire and this wire being hot and neutral, that would power something directly. So if I had that just connected straight to this bulb would be powered. But it wouldn't, because at this point, this is still alternating current. So it's AC powered electricity. Then it goes to this board. It goes through all this jumbo bullshit, all these transformers, and then this thing. That is a coil. That is a copper coil. Remember me telling you what happens to copper when you magnetize it, and by adding electricity to it, and blah 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 mumbo jumbo bullshit.
Mm-hmm.
So this plus this, and these doohickeys and the son of a bitches, all next to each other, convert the AC electricity into DC electricity. So it changes it from AC to DC now. So now we're working on different. Like if I were to go get my electrical tester, and matter of fact, that probably wouldn't be a bad idea, honestly. It'd make it a lot fucking easier to understand. Like a retarded amount easier to understand. But unless you're going to walk with me outside right now. Because for your video, you might have to. Yep.
The video's going good right now. Hold on.
Yep, you just gotta pause it.
But I'm understanding it now.
No, you don't. Oh, it makes it so much easier. It really does, honestly. Pause. Go ahead.
What are you getting at?